Hey, Mr. Harridan here. We're going to do some dimensional analysis for compounds.
That's why it's going to work.
But we have done things like this before. We have done it for elements, and I taught you how to do dimensional analysis back in Unit 1, so this is a continuation of that. Now we are going to do it for compounds here. So the mole is a counting number, remember. It's just a number, okay? 1 mole of a compound equals 6.022 times 10 to the 23rd molecules for covalent compounds and formula units for ionic compounds, okay? This is Avogadro's number, okay? This represents the molar mass of a compound represents the mass of 1 gram of mole. Okay, it's sometimes called molecular mass for covalent compounds. It is called formula mass for ionic compounds. It is rounded to 2 places beyond the decimal. It is often abbreviated molar mass. So molar mass, okay, is atomic mass for elements. For covalent, it is called molecular mass. And then for ionic, it is called formula mass. These all have the great units. You know them. G/moles. Down with the gangsters. Okay? So, remember there are 7 diatomic elements, okay? We must use their correct masses, so if I'm doing oxygen, for instance, it's 16 times 2, which is 32. Okay, so this goes back to Mr. Harridan's great tape here. So remember that the 1 mole equals the molar mass in grams, which equals 6.022 times 10 to the 23rd atoms, that's for elements, molecules, that's for covalent, and formula units, that is for ionic. Okay, so you know, that is the tape, what I call tape, the conversion factors I will be using. So let's go to the next page here. Oh, another thing here too, molecules and moles are not the same thing. Molecules we're going to abbreviate with MLCL. Moles we're going to abbreviate with MOL. Okay? Just so you know. Okay. Next page. Okay. Find the molar mass of arsenic trichloride. So here we go with arsenic trichloride. So you have an AS, you have a Cl, you have 1 of these, and you have 3 of those. Arsenic, according to my periodic table here, is 74.92. Chlorine, according to my periodic table, is 35.45. 74.92. 3 times 35.45 is 106.35. 74.92 plus 106.35. That will be 181.27 G/moles. Down with the gangsters. Okay. That's how you find the molar mass. Okay? It's just now we have more elements and we have to combine them here. So the next one we're going to do is calcium phosphate. Now this is ionic. So we have a calcium, we have a phosphorus, and we have an oxygen. There are 3 calciums. Now when we do phosphorus, this 2 distributes into the parentheses here. So there are 2 of those, and there are 8 oxygens. Calcium, I remember, is 40.08. Phosphorus, I remember, is 30.97. Oxygen is 16.00. 3 times 40.08, 120.24. 2 times 30.97, 61.94, 8 times 16, 128.00, equal sign, add those up, we have a molar mass. Yeah, that's the one I remember. 310.18 G/moles. Down with the gangsters. Okay, find the molar mass of bromine. Now remember, bromine is Br2. So you have to do Br2 times 79.90. 2 times 79.90. That would be 159.80. Remember, I'm rounding these to the hundredth place. G/moles. Down with the gangsters.
It's been great. The whole thing's been great.
Thank you. Thank you, thank you, thank you. Okay, now, here we go. We're going to use these in conversions next, right? Okay, so the key to doing this for Mr. Harridan, remember, is he uses his tape. His conversion factors. Remember, 1 mole equals the molar mass in grams, which equals 6.022 times 10 to the 23rd atoms, molecules, and formula units. Everybody loves formula units. Okay. If Rufus has measured out 79.83 grams of tetraphosphorus decaoxide for an experiment, how many moles is this? So we are going from 79.83 grams of P4O10. We are going to convert that over to moles of P4O10. I don't want to draw it that way. Yeah, I want to draw it this way. Moles of P4O10. Okay. So for this problem here, we'll set up our T-chart. 79.83 grams of P4O10. We're trying to go to moles. Grams on the top, grams on the bottom, P4O10. It helps to write the substances later. Moles of P4O10. Okay. Then we go to our conversion factors here. It says 1 mole. We're going to put 1 mole right there. Okay? And then we have to go swish, swish too, because I always forget to go swish, swish lately. Okay, so for grams, we need the molar mass. How do we find the molar mass? We have to do one of these things. We have to do the P and the O. You have to do the 4 times 30.97. You have to do the O, 10 times 16.00. 4 times 30.97 is 123.88. This is 160.00. Add those together, you get 283.88 G/moles. Down with the gangsters. So my gangster is getting flipped over here. That's why the gangsters aren't, the grams are on the bottom, my gangsters, and then the moles is on the top. We plug in 283.88 here. We divide those two numbers. And we get, notice that this is 4 sig figs. Okay, so our original number is 4 sig figs here, so we're going to round to 4 sig figs. So this is 0.2812 moles. See? Easily done. Okay. Hey, if Bill S. Preston Esquire has 4.7 moles of fluorine, how many grams does he have? So for this problem here, we have 4.7 moles of fluorine. Remember, fluorine is F2. And we're going to go up to grams of F2. So we have 4.7 moles of F2. We are trying to find the grams of F2. I forgot my scribble in the last problem. Moles on the top, moles on the bottom. Also in these problems, you always go to moles first. When you don't know what you're doing, go to moles. This one's already at moles, so we're there. Grams goes there. Okay? Okay, so moles. What number are we going to put by moles? 1 mole. What number are we going to put by grams? Molar mass. Now remember, fluorine is F2. So you have to do 2 times 19.00, which is 38.00 G/moles. Down with the gangsters. So 38.00 goes there. This number has 2 sig figs, so my answer should have 2 sig figs. So my answer to this is technically 180 rounded for 2 sig figs. Because this 0 is not significant because I did not put a decimal after it. Remember, trailing zeros without a decimal are not significant. Okay, let's go on to the next page. See what's on the next page here. Okay. Okay, more dimensional analysis here. Now remember, when we're doing this dimensional analysis here, the key to remembering doing this is you need your conversion factors, right? You need to know 1 mole equals the molar mass in grams, which equals 6.022 times 10 to the 23rd atoms, molecules, and formula units. Okay? So, how many molecules are there in 0.00375 moles of carbon dioxide? So in this problem here, we are starting off with 0.00375 moles of carbon dioxide. We are converting to molecules, mLCl, of carbon dioxide. Okay? So we set up our problem for this one here. Let's use this color here. 0.00375 moles. Put our scribble down. Times 1 conversion factor here. We are going to molecules. CO2. Moles on the top, moles on the bottom. What are we going to convert to? Molecules. Swish, swish. What number goes by moles? 1. What number goes by molecules? 6.022 times 10 to the 23rd. Okay, notice I do not need the molar mass because it does not say grams. Our original number has 3 sig figs, so our final answer here is going to be 2.26 times 10 to the 21st molecules of CO2. Okay. How many moles of copper 1 carbonate, which is Cu2CO3, are present in 5.159 times 10 to the 20th formula units of copper 1 carbonate? Okay, so this one we are starting off with 5.159 times 10 to the 20th formula units. I'll abbreviate that with the infamous FU. Formula units, of course. And we're going to go down to moles of copper carbonate. Okay. Okay. Eventually, you're going to see me do reactions, and that's why you see me draw these little arrows things here. So, like for instance, to go down from formula units to moles, I know to divide by 6.022 times 10 to the 23rd. That's what you see me doing. I'm going from moles to molecules here, so I'm going up here, so I'm going to multiply by 6.022 times 10 to the 23rd. Because some people get lost on what I'm doing, so sometimes I draw maps for the harder problems, which these are not the harder problems. So we are going to start off with 5.159 times 10 to the 20th formula units. This is a one-step problem. Going from formula units to moles. Swish, swish. Our final answer is going to come out in moles. Okay, again, our tape. What number are we always going to put by moles? 1. What number are we going to put by formula units? 6.022 times 10 to the 23rd. Now remember, when you do this one on the calculator here, you have to do 5.159 E20 times 1, which you can skip that part, divided by 6.22 E23. Or you won't get the right answer. You'll get an answer in like the 45th power, which is very wrong. And I got 4 sig figs to start off with, so I need 4 sig figs over here. 8.567 times 10 to the negative 4 moles of copper carbonate. Okay? Guys are champions. The legend is out.